Good afternoon, everyone. Today we'll be covering the Pearson Edexcel IGCSE Higher Maths Paper 2 from June 2018. It's a 2-hour calculator paper, and the total mark for this paper is 100. So this is the last paper for Pearson Edexcel IGCSE Higher Maths that uses the current spec. So I wouldn't be covering any more Edexcel IGCSE maths papers after this one. But anyways, let's get started, shall we? Question 1 states that x, 10, and y are free integers written in order of size starting with the smallest integer. The mean range of x, 10, and y is 11, and the range of x, 10, and y is 7. Work out the value of x and the value of y. So to work out x and y, we could write down two formulae. So the first formula would be we'll be using the mean. So you have x plus 10 plus y over 3 equals to 11. X plus 10 plus y equals to 33. Therefore, x plus y equals to 23. So that's one equation. Another equation we could derive from this information is the range. So you have y minus x equals to 7. And you can do y equals to x plus 7. So you rearrange the equation. That's the second equation. Since the second equation is stated in the form of y equals to something something, we can substitute 2 into 1, which gives us x plus 7 plus, no, actually it's x plus 7 equals to 23. So this you have 2x plus y equals to 23. 2x equals to, well, 23 minus 7, which is 16, so x equals to 8. So now we know that x equals to 8, we can substitute that into another equation. So you have y equals to x plus 7, so y equals to 8 plus 7, which equals to 15. So y equals to 15 in this case. This question. Yeah, so we've worked out the value of x and y here. So x is 8 and y is 15. For question 2, there's a formula given for pressure. So pressure equals to force over area. A box is put on the table. The face of the box is in contact with the table is in the shape of the face of the box in contact with the table is in the shape of a rectangle, 2 meters by 1.25 meters. The pressure of the table due to the box is 42 newtons per meter squared. Work out the force exerted by the box on the table. So the face of the box is put in contact with the tables is the shape of a rectangle, 2 meters by 1.25 meters. That allows us to find the cross-sectional area of the box. So you have 2 times 1.25 gives us 2.5 meters squared. And since we have this equation, pressure equals force over area, and we have the pressure and the area, we can work out the force by rearranging this equation so that force equals to pressure over area. No, not over, pressure times area. So the force would be 42 multiplied by 2.5, which gives us 105 meters squared for the force exerted by the box on the table. Question 3. Behnaz makes candles. She has 6 0.3 kilograms of wax and uses it all to make candles. Each candle Behnaz makes uses 210 grams of wax. Behnaz sells 2/5 of the candles for $13 each. She then reduces this price by 20% and sells the rest of the candles. Work out the total amount of money Behnaz gets by selling all the candles she made. So 6.3 kilograms of wax and uses it to make candles each with 210 grams of wax. So 6,300 grams, so this in grams, over 210 grams gives us 30. So she made 30 candles. 2/5 of 30 is 12. So 12 candles were sold for $13. The amount of money made from selling these 12 candles is 12 times $13, which gives us $156. Yes, $156. Next, we can find the amount of money made by selling the rest of the candles. So you have 3/5 times 30, which equals to 18 candles. 13 times 0.8, so a reduction by 20%. So 13 times 0.8 gives us $10.4 per candle. These 18 candles were sold at a cost of $10.4, which gave Behnaz $187.2. So the total amount of money that Behnaz gets by selling all the candles she made would be 156 plus 187.2, which gives us $343.20. Question 4 is made of 4 parts. So part A asks us to expand and simplify 3 times c minus 7 plus 2, 3c plus 4. Part B asks us to expand and simplify x plus 7 times x minus 2. Question C asks us to factorize fully 28y squared minus 21y. And part D asks us to solve 7x minus 2 over 4 equals to 3x plus 1 using algebra. So for part A, expand and simplify this. We just expand the brackets, so 3c minus 21 plus 6c plus 8. Then we collect the like terms, 9c minus 13. So that's the answer for part A. For part B, expand and simplify x plus 7x minus 2. We can multiply the outer term, the first term, so you have x squared, then the outer terms minus 2x, then the inner terms plus 7x, then the last terms 7 times negative 2 is minus 14. So that equals to x squared plus 5x minus 14. For part C, to factorize fully 28y squared minus 21y, we first need to find the common term, the common factor. So 28 and 21 are both divisible by 7, so that's a part of the common factor. Y squared and y are both factors of y, so y is another part of the common factor. So you have 7y. times 4y. So 7y times 4y gives us 28y squared. 4y then minus 3. So 7y times minus 3 equals to minus 21y. And then for part D, to solve for this, we multiply both sides by 4. So you have 7x minus 2 equals to 4. 3x plus 1. 7x minus 2 equals to this expanded, so 12x plus 4. 12x plus 4, so next we can take 7x from both sides, so negative 2 equals to 5x plus 4. Then we can remove 4 from both sides, so negative 6 equals to 5x. So x equals to negative 6 over 5, since we divided both sides by 5. Moving on to question 5. Abilene flew by plane from Dubai to Rome. The flight time was 6 hours 42 minutes. The average speed of the plane was 650 kilometers per hour. Work out the distance. Work out the distance of the of the plane. Like work out the distance the plane flew. So 6 hours and 42 minutes and 650 kilometers per hour. So first we must convert 6 hours and 42 minutes into hours. So we have 6 plus 42 over 60, which gives us 6.7 hours. So we have the speed and the time of the plane. To work out the distance, we do speed multiplied by time. So the distance Abilene plane flew would be 650 kilometers per hour multiplied by 6.7 hours, which equals to 4,355 kilometers. For question 6, Hiran invests 20,000 rupees in an account for 3 years for at 1.5% per year compound interest. Work out the total amount of money at the end of 3 years. Give your answer to the nearest rupee. So to work out compound interest, we multiply the initial amount. So yeah, the amount at the end would be the principal amount, or the initial amount, multiplied by 1 plus the percentage, so 0.015, to the power of the number of years, so to the power of 3. Work out the total amount of money in the account at the end of 3 years. So 2,000 times 1 plus 0.015 to the power of 3 gives us, it gives us 2,913.5675 rupees. However, we want our answer to the nearest rupee, so that rounds up to um yeah that rounds up to 20,914 rupees. So that's your answer right here. For question 7, there are 2 parts. Part A asks us to simplify fully 20x squared y to the power of 6 over 4x squared y squared. And part B asks us to make E the subject of the formula H equals to 3E plus F. Oops. Okay. So So for part so for part A, simplify fully this. 20 divided by 4 is equal to 5. X squared divided by x squared is just 1. Since, well, x squared over x squared is x to the power of 0, which equals to 1. So we just ignore this. Then y to the power of 6 over over y squared gives us y to the power of 4. So to simplify fully this equation, we write 5 times y to the power of 4. For part B, make e the subject of h equals to 3e plus f. We can take away f from both sides first, so h minus f equals to 3e. Then divide both sides by 3, so you have e equals to h minus f over 3. For question 8, it says from point A, Stanley walks 200 meters due east to point B. From point B, he then walks 160 meters due south to point C. Work out the length of AC. Give your answers to 3 significant figures. So for question 8, we could draw a diagram first. So from point A to point B, 200 meters east. So we have point A here, point B over here, then you have 200, and this is 200 meters. From point B, he then walks 160 meters due south to point C, so like this, 160 meters. And here you have point C. And the length of 8A and C would be this. No, actually, like this. So AC would be this length, and we need to figure out this length. Luckily, this is a right angled triangle, so we can apply Pythagoras' theorem to this. So you have AC squared equals to 200 squared plus 160 squared, which equals to 65,600. So AC would be the square root of this, which to 3 significant figures is roughly 256. So this is the length of AC to 3 significant figures. Moving on to question 9, we have a diagram that shows a regular pentagon ABCDE and a regular octagon ABFGHIJK and an isosceles triangle BCF. Work out the size of angle X. So first we should work out the sizes of the interior angles of these two regular shapes. So the size of angles within a regular pentagon would be 180 times 5 minus 2 over 5, which equals to 108 degrees per angle. So this is 108 degrees. Let's make the degrees. 108 degrees. And then an interior angle of the octagon would be 180 times 8 minus 2 over 8, which equals to 135 degrees. So this angle here is 135 degrees. Since we have these two angles, we can work out this angle here. So 360 degrees minus 108 degrees minus 135 degrees gives us 107 degrees here. So this is 107 degrees. And since BCF is an isosceles triangle, this angle is also x degrees. So these two angles are the same. So to find the value of x, we take 117 away from 180, and we divide this by 2. So 180 minus 117 over 2 gives us 31.5 degrees. So that's the size of angle x. For question 10, ABCD is a trapezium. So you have a trapezium with given lengths here. And we need to work out the size of angle X correct to 1 decimal place. So let's just hang on for a bit. So first of all, we can split this trapezium into a rectangle and a right angled triangle. So here you have your rectangle. So X equals to 90 degrees plus this angle here. Let's label this point E. So X is 90 degrees plus ECD degrees. So to figure out the um the size of angle ECD, we can use trigonometry to figure out, well, we can use trigonometry to calculate it. So length EC is 12.5 centimeters, so that's one side. Length ED is 24.3 minus 16, which is which is 8.3 centimeters. So we have two sides of this right angle triangle. So we can use the trigonometric function tangent of ECD to find the size of ECD. So tangent is opposite over adjacent, so you have 8.3 divided by 12.5. So ECD degrees would be tangent time, well, arctangent, so like the inverse function of a tangent, arctangent times 8.3 over 12.5. And um that gives us 33.6 degrees to 1 decimal place, of course. To find the size of X, we can now add 90 degrees and 33.6 degrees, which is 123.6 degrees. So this is the answer to question 10. Question 11 gives us a table that shows the information about the amount of money spent on holiday by each of 120 families. Question A asks us to write down the modal class. Question B wants us to complete the cumulative frequency table for the information in the above table. So you have a table for cumulative frequency. Question C wants us to draw a cumulative frequency graph for our table. So you have money spent, cumulative frequency, and yeah, a, a grid where we can draw a graph on. So we will copy this as well. For question D, we need to use our graph to find an estimate of the interquartile range. And for question E, we need to use our graph to um to find an estimate for the number of families that spent more than £450 on holiday. So first of all, for part A, the modal class is the class with the highest frequency, so that's 100 M 200, so M is between 100 and 200. Complete the cumulative frequency table for the information in the table. So between 0 and 100 pounds, you have 10 families. 0 and 200 pounds, you have 10 plus 36, so 46 families. 0 and 300, you have 10 plus 36 of 34, so that's 80 families. 0 to 400, you have 10 plus 36 plus 34 plus 20 families, which gives us 100 families. Then 0 to 500, you have 15 more families, and 5 more families for 0 to 600. So here's our cumulative frequency table. On the grid, draw a cumulative frequency graph for your table. So for 100 pounds spent, that's 10 families. For between 0 and 200, that's 46 families. So 46 is 42, 44, 46. Between 0 and 300, that's 80 families. So 80 is up here. Between 0 and 400, that's 100. 0 and 500, 115. That's up here. So 112, 114, 115. Between 0 and 600, 120. So 120 families all the way up here. So that's all the families, and that's the highest amount of money spent. So now we just need to draw a line through these points. So you have 0 to 1. So you have 0 to 100, then 100, 100 to 200, and 200 to 300, then 300 to 400, 400, yeah, 300 to 400, 400 to 500, 500 to 600, like this. So now we have part D and part E down here. So part D wants us to use our graph to find an estimate for the interquartile range. So what we can do here is for the lower quartile, the cumulative frequency will be 30. So we draw a line here from 30 to the graph over here, then down like this. Actually, yeah, down like this, like this. Then you go to the upper quartile, so you have 90. You draw your line all the way here, then draw your line down to here, so 350. So the interquartile range is this part, this here, so 350 pounds minus this here, so 100, 165 pounds. So you have 350 minus 165, which gives us 350 minus 100. That gives us 185 for the interquartile range, which is a valid amount. Moving now to part E, we need to use our graph to find an estimate for the number of families that spent more than 450 pounds on holiday. So more than 450 pounds, you draw a line from here. This is 450 pounds up to here. Then from here we draw a straight line to this part of the graph. So this is 108 families, so 108 families spent less than 450 pounds. So 120 minus 108 means 12 families that spent more than 450 pounds. Moving on to part 12. ACD are points on the triangle center O. AB and CB are tangents to the circle. Angle ABC is 74 degrees. Work out the size of angle ADC and show you're working clearly. So, so the angle between a radius and a tangent would be 90 degrees. So this is a right angle, this is a right angle. So 74 degrees plus 90 degrees plus 90 degrees gives us 254 degrees. So this angle here would be 360 minus 254 degrees, which gives us, let's see, it gives us, well, 106 degrees. So that's the angle here. To find the size of angle find the size of angle ADC, so this angle over here, we simply apply one of the circle rules, which is that let's just type it out. Angles at a circumference are twice the size of angles at no are half the size are half the size of angles at the center. So this angle is at the center, so AOC is an angle that passes through the center. ADC passes through the circumference, but they're subtended from the same 2 points A and C. So that the size of ADC will be 106 divided by 2, which is 53 degrees. So that's the answer for question 12. For question 13, the straight line L1 has equation y equals to 6 minus 2x. The straight line L2 is perpendicular to L1 and passes through the point 47. Find the coordinates of the point where L2 crosses the x-axis. So the coordinates of the so if L2 is perpendicular, the gradient will be 1/2, so y equals to 1/2 x plus c. Since the gradient of straight line L1 is -2, so the perpendicular line will have a gradient of 1/2 x. So we substitute in the points 7 and 4, so 7 equals to 1/2 4 plus c. 7 equals to 2 plus c. C equals to 5. So y equals to 1/2 x plus c. The coordinates of the point where the line L crosses the x-axis would be where y equals to 0. So 0 equals to x half x plus 5. Yeah, so half x plus 5 here and 5 there. So take away 5 from both sides. Negative 5 equals to half x. Then divide both sides by half, so x equals to negative 10. So the coordinate of interest is negative 10, 0. Question 14 states that 128 equals to 4 to the power of 2x times 2 to the power of x. Work out the value of x. So 4 to the power of 2x would be 2 to the power of 2 to the power of 2x times 2 to the power of x. So 2 to the power of 2 to the power of 2x would be 2 to the power of 4x times 2 to the power of x, which is equal to 2 to the power of 5x. So that's 128. And 128 is equal to 2 to the power of 7. So 5x equals to 7. Therefore, x equals to 7 over 5, which equals to 1.4. So question 15 gives us a Venn diagram here, and 7, 3, 8, 1, and 1, 4, and 9 represent the number of elements. Find n, the number of elements where A union B, the number of elements where A inverse intersects C, and the number of elements A inverse union B inverse. So let's just copy the Venn diagram and also the questions. So you have the Venn diagram and you have the questions. So number of elements A union B. So 7 plus 3 plus 8. So 7 plus 3 plus 8 gives us um 19 elements where A union B. So A union well actually 7 plus 3 plus 8 plus 1, since this is also part of B, so you have 7 plus 3 plus 8 plus 1, so A union B right here gives us 20 elements. A inverse intersects C, so things are not in A, so you have this, and this intersects C, so C has this and this. We only care about the ones which have two lines on them, which is 1 and 4. So A inverse intersects C will be 1 plus 4 equals to 5. And then for part 3, the number of elements where A inverse union B inverse. So the elements in A inverse are 7. No. The elements of A inverse are 8, 1, 4, and 9, while the elements of B inverse are 7, 4, and 9. So all the underlined elements here will be involved, so all of them except 3. So 7 plus 8 plus 1 plus 4 plus 9 gives us 29 elements. In question 16, there are 8 counters in a bag. There's a number on each counter. Fiona takes a random 3 of the counters. She adds the number of the 3 counters to get her total. Work out the probability that her total is an odd number. So there are multiple combinations, so you can have odd, 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 even, 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 odd, even, and even, even, odd. So odd, odd, odd would be 1, 2, 3, so 5 over 8 times 4 over 7 times 3 over 6. Since a 1 counter is removed, it's not replaced. So 4 over 7, so 5 over 8 will be 1, 2, 3, 4, 5 odd numbers. 4 over 7 will be one of these taken, so you have 4 odd numbers out of 7 counters in total. And the same for the next one. As for odd, even, even, you have 5 over 8 again, but multiplied by 3 over 7, since you have 2, 4, 4, then multiplied by 2 over 7. For even, odd, even, you have 3 even numbers over 8 at the beginning, multiplied by 5 odd numbers over 7 remaining counters, then multiplied by 2 remaining even numbers and 6 remaining counters. Then even, odd, you get um 3 even counters over 8 counters multiplied by 2 remaining even counters over 7 remaining counters, then multiplied by 5 over 6. So odd, 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 that the multiplication here equals to 60 over 336. The next equation here of 30 over 336. This one it's 30 over 336. And this one you have 30 over 366. So you add these fractions all together, so this plus this plus this plus this equals to 150 over 336. And if you divide 150 over 336 by 6, so this divided by 6 over 6 gives us 25 over 56, which is the simplest form of the fraction here. So moving on to question 17. For part A, we need to use algebra to show that 0.436 recurring is equal to 24 over 55. And for part B, we need to show that 20 root 20 plus root 80 over root 3 can be expressed as root a, where a is an integer. Show you're working clearly. So, so for part A, use algebra to show that 0.436 recurring equals to 24.24 over 55. So let's just say that x equals to 0.436 recurring. So 100x would be equal to 43.636 recurring. So so basically if we remove the recurring sign, 0.436 recurring is basically 0.436363636 so on whatever, and 100x is 43.636363636. So since these digits are recurring, are are in the same place and are the same in 100x and x, we can take x from 100x to get 99x, which is equals to 43.6 minus 0.4, which is 43.2. The reason why I chose 100x is that if I chose 10x, the decimal places will be in the wrong place, so 10x would be 4.363636, and this just doesn't line up, so 10x wouldn't work. So x and 100x, this sequence of digits is recurring and goes on forever. So these common decimal places can be subtracted to get 99x, so 40, which is 43.2. So 99x is 43.2, so x equals to 43.2 over 99, which is equal to, if you multiply both sides by 5, you get you get um you get, let's see. Yeah, you get 216 over 495, which equals to, if you divide both sides by 9, you get 24 over 55, which is the answer to this question. So this is part A. Let's just be clear. So for part B, show that root 20 plus root 80 minus root 3 can be expressed in the form of root A, where A is an integer, like this. So root 20 plus root 80 can be written as root 20 plus 2 root 20 over root 3. So 80 can be rewritten as 2 root 20, since root 80 is just root 4 times root 20, and root 4 is equal to 2, so that's how you get it. So this is equal to 3 root 20 over root 3. Multiplying the 3 into the root, we get root 180 over root 3. Since 3 is equal to root 9, and 20 times 9 is 180, so root 180 over root 3 gives us root 60. So that's the answer to part B. Moving on to question 18, we need to solve the simultaneous equations 2x squared plus 3y squared equals to 14, x equals to 2y minus 3, show clear algebraic working. So first of all, we can substitute this equation into the x over here. So 2 times 2y minus 3 plus 3y squared equals to 14. So 2y minus 3 squared would be 4y squared minus 12y plus 9 plus 3y squared equals to 14. So we multiply this out by 2, so 8y squared minus 24y plus 18 plus 3y squared equals to 14. Adding the like terms together and taking 14 from both sides, we get 11y squared minus 24y plus 4 equals to 0. So So next we can factorize this. So to factorize an equation where a is not 1, so you have 11y, we could split this middle term up. So 24y can be split into two terms which add up to minus 24y, but multiplied to 4 times 11, so 8 times c, so 44y. So two numbers that multiply up to 44 but also can be added to make it minus 24y would be minus 22y and minus 2y. So 11y squared minus 22y minus 2y plus 4 equals to 0. So, so we can split this equation in half. So you have 11y minus 2 on this side, and you have minus 2y minus 2 on this side. So one of the factors here is y minus 2. The other factor would be 11y minus 2. So, so this would be this equation factorized. And we can use this to find our answers for the question, which is y equals to 2 over 11 and or y equals to 2. So these are two answers for y. As for x, for y equals to 2 over 11, x equals to 2y minus 3. So y equals 2 over 11, x equals to 2 over 11 minus 3, which equals to 4 over 11 minus 33 over 11, which equals to negative 29 over 11. And for this side, you have x equals to 2 times 2 minus 3, which equals to 4 minus 3, which equals to 1. So x equals to negative 20y over 11, or x equals to 1. So there are so these are the two solutions, and if you want to make it clearer, you can write that y equals to 2 over 11 and x equals to negative 29 over 11, or y equals to 2 and x equals to 1. So these are the two possible combinations of values. Moving on to question 19, we have a equals to p minus q over t, where p is 8.4 correct to two significant figures, q is 6.3 correct to two significant figures, and t is 0.27 correct to two significant figures. Work out the upper bound for the value of a. Show you're working clearly and give your answer to correct to one decimal place. So to get the upper bound of a, you have the upper bound of p, which equals to 8.45, the lower bound of q, which is 6.25, and the lower bound of t, which is 0.265. The reason for this is that we want the highest value of p and the lowest value of q, so we have the highest numerator, and we also want a low denominator, so we have the lower bound for t. So a equals to 8.45 minus 6.25 over 0.265, and that correct to one decimal place is 8.3. So that's the upper bound of a. Moving on to question 20, we need to solve the inequality 4x squared minus 5x minus 6 is greater than 0. So first, we need to solve the equation. So 4x squared minus 5x minus 6 equals to 0. Using the same method for factorization I used in question 18, we have plus add to minus 5y and multiply to negative 24y. So to get to minus 5y, we need to and to multiply to minus 24x. Yeah, minus 5x and minus 24x. The two values of coefficients for x that will fit this criteria would be 3x and negative 8x. So you have 4x squared minus 8x plus 3x minus 6 equals to 0. Split this equation down the middle. Factorize both sides, so you have 4x x minus 2, 3x minus 2, and so one of the factors is x minus 2, and the other factor would be 4x plus 3. So 4x plus 3x minus 2 equals to 0. So these are the two factors for this equation here. So using this, we can find that x equals to negative 3 over 4 and and x equals to 2. Now we just need to know which direction the inequality sign goes. Since the coefficient for x squared is positive, the graph would look like this. So it goes up like this, well, concave up. So here you have negative 3 over 4, and here you have 2. So the area greater than 0 would be this area here. So you have x is less than negative 3 over 4 and x is greater than 2. So that is our answer for question 20. Moving on to question 21, here's the graph of y equals to f of x. Question A asks, on the grid above, draw the graph of y equals to 2 f of x. So let's copy this first. So let's just copy this graph and the question. So you have this, and you have this. Okay, so part B of this question gives us another graph which is labeled y equals to f of x. So now actually this is the same graph. It's just it's the same graph put on a different grid. So here's the graph again. And moving down, question B asks us to draw the graph of y equals to f negative x on the grid above. So we have two graph translations questions. So for part A, 2f of x would be a vertical stretch of 2. So from 2 negative 1 you'll get to 2 negative 2. So you get down to here. Then 1 3, this point here. 1 3 would now be 1 6. So you have this. And then the mirror image is for this side. So 4 negative 2 instead of 4 negative 1, all the way up to 1 6. So you have this. On the grid above, draw the graph of y equals to f of negative x. So f of negative x is a reflection on the x-axis. So reflecting this on the x-axis, we have 2 negative 1 going up to negative 1 3. Then negative 1 3 we go down to negative 4 negative 1 like this. So for question 22, we need to express this massive equation as a single fraction within its simplest form. So this question will require a lot of factorization and simplification. So this left-hand side, we can factorize this fraction here. So the top side, so the top 4x squared minus 25, that's the difference of two squares. So you have 2x plus 5 multiplied by 2x minus 5. So this is let me think. So this is how you factorize the numerator for this fraction, and the denominator 5x squared plus 2x plus 7. So let's just zoom into that a bit. So 5x squared plus 2x minus 7. We use the same method as we did back in question 18 and question 20. So we have this, add to 2x, multiply to minus 35x, and this, and you get 7x and negative 5x, so 5x squared minus 5x plus 7x minus 7 equals to 0. Split this equation in the middle, factorize it, and write down the write down the equation in factorized form. So you have this. So 5x plus 7x minus 1 is the denominator factorized. As for the for this here, we can cross multiply to combine this into one fraction. So 2x 2x minus 5 minus 3x minus 3 over 2 2x minus 5 x minus 3. So you have this. Then we basically copy this down here, except that we solve for this top for the numerator on the right hand side fraction. So you multiply by 2x minus 5. So you have 4x minus 10 minus 3x plus 9. So you have negative 10 plus 9 is negative 1. 4x minus 3x is x. So you have x minus 1 over 2x minus 5, x minus 3. So now we multiply this, but we can cancel out factors that appear on the denominator of one fraction and the numerator of the other. So you have x minus 1, so this gets cancelled out. 2x minus 5 also gets cancelled out. So now the fraction is just 2x plus 5 over 5x plus 7 times x minus 3. So that's the answer to this question. Question 23 states that OAB is a triangle. The vector OA is A, OB is B, C is the midpoint of OA, D is the point of AB such that AB and DB is 3 to 1, E is the point such that OB equals to 2BE. Using a vector method, prove that the points C, D, E lie on the same straight line. So OB, 2B, so A. So first we draw a diagram. So let's draw a triangle like this. You have point O here, then point O, then point A, and point B. C is the midpoint of OA, so you have point C here. D is the point of AB, so AD, DB is 3 to 1, so AD, DB is 3 to 1 like this. And E is the point such that OB is 2BE, so BE is half of OB and in the same direction, so we continue this line until we reach E. So this is a diagram of our question here. Let's just write down the vectors for good measure as well. So this one is so this direction it's vector A and this one is vector B. So to prove that the points C, D, E lie in the same straight line, so C, D, E like this, no actually, C, D, and E like this. To prove it, we state that CD and DE are parallel. They must be parallel in order for CDE to be a straight line. So CD is well CA plus AD. So AD so CA over here is equal to half A, but AD is 3/4 of AB, so let's just figure out AB first. So AB equals to AO plus OB. Forgot to add the arrows to all of them, so here I'll do it. I'll do it now. So CD, CA, AD, CD, C, like this. So AO plus OB, and that equals to, so AO is just OA reversed, so you have negative A plus B, which equals to B minus A. So CD is CA plus AD, so CD is half A plus 3/4, since this ratio here, 3:1, AD is 3/4 of the length of AB, while DB is 1/4 of the length of AB. So if 3/4 B minus A, which can be factorized into, well, 1/2 A plus 3/4 B minus 3/4 A, which is equal to 2/4 minus 3/4. That's so 3/4 B minus 1/4 A. As for DE, this vector over here, it is equal to DB plus BE. So DE equals to 1/4 B minus A. Since DB is the remaining quarter of AB, and BE is equal to half of B, so 1/4 B minus A plus 1/2 B, and that equals to 1/4 B minus 1/4 A plus 1/2, yeah, 1/4 A plus 1/2 B, and that equals to 3/4 B minus 1/4 A. So as you can see here, these two expressions are the same, so you can write that CD equals to DE. Therefore, CDE is a straight line. Moving on to the last question on the paper, question 24 is 3 parts. So 24a, express 7 minus 4x minus x squared in the form of p minus x plus q squared, where p and q are constants. Use your answer to part A to solve 7 minus 4y plus 3 minus y plus 3 squared equals 0. Give your answer in the form of e plus or minus f, where e and f are integers. The curve C has equation y equals to 3 minus 5x plus 1 squared. The point A is the maximum point on C. Write down the coordinates of A. So let's just copy this question down. So 24a, express 7 minus 4x minus x squared in the form of p minus x plus q squared. P and q are constants. So A, we can first rearrange this equation so that minus negative x squared minus 4x plus 7. So this is the equation rearranged. So we can also factorize it so that this is x squared plus 4x minus 7 multiplied by the negative by by a negative coefficient. So using this, we can complete the square for this equation. So you have negative x squared plus 4x plus 4 minus, well, yeah, so 7 plus 4, that's minus 11. So x squared plus 4x plus 4 minus 11, that's the equation factorized. Not factorized, with the square completed. And we can And we can factor out the minus 11 by doing minus x squared plus 4x plus 4 plus 11. So negative x plus 2 squared plus 11. And that equals to 11 minus x plus 2 squared. So this is the equation in this form over here. For part B, using your answer to part A, solve 7 minus 4y plus 3 minus y plus 3 squared equals to 0. So we basically replace the x of y plus 3, so 11 minus y plus 3 plus 2 squared equals to 0. So 11 minus y plus 5 squared equals to 0. So we can add y equals to y plus 5 squared on both sides, so 11 equals to y plus 5 squared. And we can square root both sides, so you have plus or minus square root 11 equals to y plus 5. Then take 5 from both sides, so y equals to negative 5 plus or minus root 11, which is the answer to this question. For part C, write down the coordinates of A where the equation is y equals to 3 minus 5x plus 1 squared. So to rearrange this equation, we have y equals to negative 5x plus 1 squared plus 3. So this is the equation rearranged into what was it called again? Vertex form. Yes, vertex form. So this is vertex form. So you have So for vertex form, y equals to a constant, times x minus h squared plus k, where hk is the vertex. So the h here, since this is plus 1, h is equal to negative 1, and k equals to 3, since plus k. So k equals to 3, h equals to negative 1. Therefore, the vertex is negative 1, 3. Since we finished the paper, we can start covering the mark scheme. So let us open the mark scheme. Um, here. So this is the mark scheme for summer 2018 for Pearson Edexcel International GCSE and Mathematics A4 MA1 Paper 2 HR. So there's just a bunch of guidance and oh, here's the mark scheme already. So let's so let's so I'll just stop talking and you can just look at the mark scheme. And that's all for today. Thank you for watching and I'll see you next time.